Hello everyone, my name is Somnath Burade. I am student of GH Raisoni Institute of Engineering and Technology, Wakoli, Pune, and my team member name is Sushma Alunskar, Shumam Mujade, and Vishal Adke. Today we are discuss about the project Credit Card Fraud Detection using machine learning. In this project, we use the dataset which is credit card transaction. In this dataset, there is total 2,84,807 transaction of data. In this dataset, there is total 31 column and 2,84,807 rows. Here we can see that there is total rows in dataset. Here is 2,84,807, and in this dataset there are total 31 column. First is time. After that, V1 to V28 is our features of credit card, and amount and class. In class in class column there is 0 and 1 value. 0 means normal transaction and 1 means fraudulent transaction. Here we can see that this is our program of the project. For this we use the different libraries like pandas. Panda is useful for the data, like import the data set. Here we can see that this is the path of our data set. After that we run this command df.head. This is useful for the showing the first 5 rows of our data set. Here we can see that there is no all the columns are visible, so that we use this line of command pd.option.display.maximum columns is equal to none. This is useful for the display all the columns. Here we can see that here the display the show the all columns. df.tails, it is useful for the uh, see the tails of the dataset. Here we can see that the tails of the dataset. df.shape, this is useful for the shape of the showing the shape of the dataset. In this dataset there are 2,84,807 rows and 31 columns. df.info, this is for check the there is any null value or data types of the data. Is null is some means how much value in our dataset are null, where you can see that there is no any null value. sklearn standard processing, sklearn processing import standard scalar. This is used for the we can see that their amount is not in standard, so we convert the amount in standard form. For that we use the standard scalar. Here we can see that after this we get the amount in standard form. There we drop the time columns for the data pre-processing, like dimension reduction. You see, we use the time, we drop the time columns. Here we use the axis 1. Axis 1 means we drop the column. After that we check the shape of the data set. There we can here we can see that there only are 2,84,807 rows and 30 columns. After that we check the there is any duplicate value. For that we use this command df.duplicate.any. So we have in a dataset a duplicate value, so we drop the duplicate value. After the drop we get the 2,75,663 rows and 30 column. There is a 909,144 duplicate value in our dataset. After that we check the how much value are fraud and normal transaction. Here we can see that 0 means normal transaction. In our dataset there is, after removing duplicate value, we get the 2,75,190 normal transaction and 473 is fraudulent transaction. Import cborn as ESB. This is used this library we use for the plotting the bar chart. Here we can see the chart. Here we can see the difference of normal transaction and for fraudulent transaction. The data set is highly unbalanced, so we use the undersampling. Using undersampling, we check the shape of data like normal transaction and fraudulent transaction. After that, we create the normal data as equal to the fraudulent data. Like fraud data is 4 lakh 473, and we create also the normal transaction is 473. After that, we here we can see that the we are normal sample shape is 473. After that, we concat the normal and fraudulent in one data using new DF. So we create the new data set, name is new DF. In this, we can see that their normal transaction is 473 and fraudulent transaction is 473. After we can here see that we check the head and the index is not in order. So we can here this command we run and create the indexing form like 0 1 2 3 4 5, and this is tail. Total is 945 rows, means total value of the data is 946 transaction. After that, where here we create the features and target like independent variable and dependent variable are separate, where we drop the class column using axis 1, and we put this class in a y variable. After that, we split the data in training and test set. We use the 20% for the test and 80% for the training. After that, we use the basically we use the thin algorithm, logistic regression, decision tree, and random forest classifier. First, we create the model on logistic regression. Here, this is the code of the model of logistic regression. We name as the LR. After that, after run of this code, we predict the result like accuracy. We get the 93% accuracy. Precision score. We also check the precision score, recall, and APON score. After that, we create the model on decision tree classifier. We can also check the accuracy of decision tree. Here we get the accuracy is 92%. We also check the precision score, recall score, and APON score. After that, we create the model on random forest classifier. Random forest classifier, we also check the accuracy. We get the accuracy score is 94% using undersampling. We also check the precision score, recall, and APON score. After that, we compare the both three algorithms. Here we can see the difference. Logistic regression have 93 accuracy, 93%. Decision tree is 92, and random forest is 94. After that, we create the bar chart using ESB bar plot. Here we can see the difference in the our algorithm. After that, we check the accuracy using the oversampling. Here we can use the oversampling. This is oversampling code. Here we create in oversampling we create the data using the libraries mode name as the X race and Y race mode field. Here we create the fraudulent data is equal to the normal data. Here the value of normal data is 2,75,190, and we also create the fraudulent data is 2,75,190 transaction. After that, we split the data in train and test. We use the 20% data for test and 80% for train. We create the in oversampling, create the logistic regression, decision tree, and random forest algorithm. First, we create the logistic regression, and we get the accuracy 94% using oversampling. We get also we check the precision score, recall, and F1 score. After that, we create the decision tree classifier model we check the accuracy. We give the get the higher accuracy as compared to the undersampling. We get the accuracy 99% in decision tree. We check the precision score, recall score, and APON score. After that, we create the random forest model. In a random forest, we get the higher accuracy, like 99.99% accuracy. Precision called recall score which 1 and APON score is 99.99%. After that, we compare the both three algorithms value. Here we get the logistic regression at 94.56%, decision tree has 99.81%, and random forest has a 99.99% accuracy. So we here we plot the bar chart using SB bar plot. After that, we save the model on random forest because we give the highest accuracy of the random forest algorithm. So we save the model of random forest using joblib library. We save the model name as a credit card model. After that, we put the value of the transaction for check the transaction is normal or fraud. If our values predict the 0, then transaction is normal, and if the values predict the 1, then transaction is fraudulent. So this is give the fraudulent. This give the output as a fraudulent transaction. After that, we create the GUI using the Winter library. This is the code of our GUI. After run this code, we give the this type of GUI. Here we put the values of transaction, and after that we predict the value. So we give the output. Yeah, fraudulent transaction. Also we check this in our GUI also. Here final prediction from the model credit card fraud detection system is a fraudulent transaction. So this transaction is a fraudulent transaction. Thank you.